I am a computer vision engineer at Solar AI, which is a Singapore-based startup. I work there, try to make solar energy accessible to all by using computer vision. As I mentioned, that using computer vision, like people can access the solar energy in much cheaper methods, and try to access renewable energies in general. So today in this discussion, I'm going to be speaking about how computer vision or machine learning in general is affecting the climate space. And and by no means I claim to be an expert in this, but I'll just try to cover as much as I can. So first of all, let me talk about how we are changing solar panels adoption through machine learning and solar AI. The way we do it is that we gather satellite images from all around the world, but generally we are focused in Singapore for now. So for in Singapore, we generally gather satellite images of Singapore main island area and other islands around it. And what we try to do is to detect rooftops on the island and try to detect the features of the rooftop. Let's say the rooftop is flat, or it's like tilted, or what is the direction of the rooftop, what are the obstacles like air vents present on the rooftop, which helps basically solar panel installers to get an estimate on how much PV capacity does a particular area or a particular rooftop have. Generally, for if you like see right now, 30 to 40% of the cost of installing a solar panel goes into analyzing the rooftops solar potential. So a company would like generally send a salesperson to a rooftop owner's house, and a house owners and he will go to the rooftop and he will measure by hand. This takes around like 2 to 3 days for a particular area. So by using computer vision, we can just narrow it down to like 1 or 2 hours of time. And it also saves us time because we don't have to generally hire someone who goes to analyze the rooftops. So in this way, we are helping basically the customers who are trying to adopt solar panels, that who can access the solar panels like 30 to 40% cheaper from the solar installers. Other than that, I also worked with an African startup called Need Energy. That startup basically tries to. So generally, what happens right now in Africa is that sometimes the energy production is greater than the household requirements. And what the energy production company does is basically the extra energy that they dump it into the ground, which is basically very, very harmful. Just in the case that the resources that are required to generate the electricity goes into waste. So what does that startup is trying to do is to predict the average household's energy requirement for the future. So whenever try to predict the household's requirement, you say to the energy company that this is kilowatt per hour energy that we require for the past couple of months, and you should not like generate more than that. So to do that, basically you can look at the local climate, but that startup particularly installed a customized meter into the households, and that meters take out energy information on how much the household is consuming, and that we are using that data to, and the local climate as well, to predict the future energy requirements. And this way we can schedule when to bring the new renewable energy as well as like solar panels online in that particular area as well. um, Other than that, like speaking about solar energies, not a very specific computer vision perspective, but using machine learning, we can also try to evaluate new particles that can store solar powers. These are generally called solar fuels. If you ever heard about it, these solar fuels you can try to evaluate using machine learning by trying different molecular structure. And this is how like solar panels was first, you know, invented in general. And we can also try to devise some structures for CO2 absorbent for greenhouse gases emission and similar stuff like that. Other than that, we can also try to change and reduce energy anxiety. So when you think about a electrical car, right, you always think about how much it's going to last. There is always an anxiety in your mind that when I buy an electrical car, it might run out of electricity in the middle of nowhere. So how can I change this so that people can adopt electrical vehicles? And this is, as you can know, that electrical vehicle adoption is very, very crucial for environmental change in general. So having an electrical vehicle, you can actually easily predict using machine learning that what is the charging behavior and what is the consumption behavior of a particular user, and you can preemptively say to them that this is how much time you should charge, or this is when you will be charging your vehicles consistently. One of the things that I worked in past as well was detecting wildfires using satellite images again. So this is one thing that we worked on for quite a while now. Uh, so generally, wildfires emits a lot of carbon, greenhouse gases, and this generally consumes like 8% of emits out actually 8% of total greenhouse gases all over the world. And what we tried to do was try to detect these wildfires using computer vision models that can easily predict or differentiate between a wildfire and a normal, forest area. And that was really, really important in Brazil area, because that's where like they face a lot of wildfires, and yeah, that helped them a lot. One of the things that I have closely monitored was an hydroponic project. So if you know about hydroponics, is basically growing trees without soil, and this is where like you plant a tree on a tube where you constantly supply them with minerals through water, and these trees are like grown very fast and grown like rapidly. They don't require soil, they don't generally require sunlight because they are fed with UV lights separately. This is a way of farming where you require a very less amount of land because there is no soil involved, and you can like grow vertically. So this is important in countries like Singapore, where they don't have a lot of forest land with them. So what we did was basically try to put a camera on top of these plants and detect when a plant is having less minerals than other. And as soon as a particular plant is getting less minerals, we just put in more minerals to that particular tube. So how we do that is basically classifications. So we built a classification model between a dried out plant and a healthy plant, and we fed that into the system, and the camera was able to detect that where the machine was able to detect where the plant is dying. And this is how we can increase the growth in hydroponics, which so hydroponics is very, very good, is because like it requires 90% less water than a normal agriculture farmland. So this way we can also save water in agriculture. um Yeah, that's about what I have thought for now. This is like, these are the projects that I've already worked on. There are like many, many other projects that requires our attention, the community's attention. But these are the projects that I have worked on for my past career. Computer vision is not so it's a very big and a vast field where it also so image classification, image segmentation, instance segmentation, these are all part of computer vision in general. Computer vision is a bigger umbrella which also contains some image pre-processing techniques as well. So it's not machine learning in all. So computer vision has image processing as well as machine learning inside it. So image classification is basically a part of computer vision.